functions, yes, you need to know basic trig values of unit circle values, or multiples of 30 degrees, 60 degrees. Are you going to have to do all that trig stuff we did last year in pre-cal? No. But you are expected to be able to do basic trig values without a calculator. Yes?
So is there anything trig-wise that I can't do with the little hand?
You're going to have to memorize new definitions of trig functions, like derivatives, but
Trig stuff, I can use my hand.
I think you can use your hand for.
That's what got me through last year.
Okay. And the great thing is that, Adam, you can, once I teach you the rules for derivatives, you can do these without really having a lot of trig background. The hard part's going to be evaluating the trig functions at an angle. But if you don't really have to know what it is to know the derivatives, you just have to memorize them, which means you have to memorize these. There's no getting around it, right? Oh, did I have to put blanks here? Why did I just give you all these? This is ridiculous.
You didn't even put
You're
a title
supposed to
on it.
fill it in. It's supposed to be the blank that you have to fill in.
You forgot to cover the blank.
I forgot to cover it up. The derivative of sine is cosine. And think about the graphs of sine and cosine. The derivative of sine goes like this. The derivative, or sorry, the graph of sine goes like this. The graph of cosine. Oh, I'm screwing up. Something like that. That's terrible.
That's much better.
Anyway, if you took the slope of the point at any point on sine, its value would be cosine. So remember that this is the notation for derivative, and you just need to know this. Next week we'll do like around the world flashcards with derivative rules.
Sick. Adam's
The derivative of cosine is negative sine. I don't know why I'm negative sine. I'm going to give you a rule in a minute to help you. I can't believe I'm letting you not write all these.
Is there a song?
There's no song, but I'm going to give you a trick.
song.
Derivative of sine is cosine. Derivative of cosine is negative sine.
Is that what it is? It's the trick right here.
That's not the trick, but let's practice this.
That's what? No, you can't
Let's
talk
do the quotient rule.
Sure.
Okay, so we have a lot of rules that we've been working on the last couple weeks for derivatives. One of them is the quotient rule. So if you want to take a derivative of a quotient, so if you had, that just means derivative of. If you want to take the derivative of a function divided by a function, who can tell me the quotient rule?
Derivative of x
We say f
times g of x.
prime of x times the bottom, so the derivative of the
G
top
prime of
times
x
the bottom minus
times f of x.
G
all
prime of
over
x.
G of x.
Oh my gosh, you're talking too fast.
The denominator squared because.
I missed my song, Adam.
It wasn't like so.
It wasn't that good.
Send to us.
But the rule is derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So now we can throw trig in there, because now we know how to take the derivative of sine and cosine. What's the derivative of sine? Cosine. So we say cosine of x. Don't forget to put your x there, right? Cosine is nothing if it doesn't have x next to it. So I say cosine, but I'm going to write cosine of x. Times the bottom, which is cosine x minus 2. Minus, what would the derivative of cosine x minus 2 be?
Negative sine x minus 2. No, just negative sine x. Ha!
The derivative of cosine is negative sine, so can I change this to positive sine? Since it's minus a negative sign. And then remember the derivative of a constant, if we're talking about derivative means slope, the slope of a constant is 0, so that's why the derivative of the constant
Then it's all over 2a.
is
Right?
0. All over, oh wait, I forgot something. Times the top.
So it's the 8.
Did you do that already? It's f of x, the sine of x.
Yes.
All over the denominator squared.
We go.
We go.
Good work, guys.
You think we should leave our answer like that?
Yep.
Yeah.
What's calculus? We know how to do it. We've done enough calculus. So it's saying calculus, right?
So we can say cosine squared, right? Cosine times cosine is cosine squared, just like x times x is x squared. And that would just be minus 2 cosine x plus sine times sine is sine squared all over cosine x minus 2 squared. And I'm just gonna leave that on the bottom. Yeah. Remember those awesome Pythagorean identities?
Wow, this is the second time you've taken
This is really, I told them it's the worst day ever to join calculus because it's the day that you're like, I needed what I did in pre-cal last year. Like, up until now, like, we really haven't done that much stuff that we were using exactly what we did in pre-cal.
Sine
But
squared plus cosine squared equals what?
yeah, Pythagorean identity. I told him we'll just fill it in as we go. And he's taking Math 137 next semester, which is all trig, and so
The good thing is,
You should teach math 37 first semester, not second semester.
yay, so it's 1 minus.
so sine squared plus cosine squared equals 1. So we can say that that's just 1. So that's 1 minus 2 cosine x over cosine x minus 2 squared.
Done.
Really, sine squared plus cosine squared equals 1 is the only identity that you're going to be expected to know on a regular basis. Every now and again in the book, they throw another one in there, and I always say they just mean, like, they just like to show you that you're supposed to remember everything you've ever learned in your whole life, but you don't. On the AP exam, besides being able to evaluate trig functions at unit circle values without a calculator, and knowing sine squared plus cosine squared equals 1, I don't think there's that much other trig on there. So maybe some stuff will come back about graphs. They're talking about continuous functions and which one of these have a limit. You would have to be somewhat vaguely familiar with the graphs, but not a ton of trig stuff on the AP exam. So that's kind of nice. I think, was there identity that's 1 minus 2 cosine x?
Nope.
Maybe.
No, there wasn't.
The world is
Nope.
Sine.
Wait.
So now I have to consult my book.
I can't even speak your language right now.
You
What
need
did
a
you say?
doctor.
She has
I have new
37.
ones over there. My life is too busy to transfer stuff right
You
now.
can take time right now.
Her life is too busy to help students in the morning, students. You get in here and she helps you for like 2 minutes. She's like, all right, I'm leaving. That's the first time a teacher's ever said they hated me.
They all do.
They all.
Wow. I'm dropping out of school.
Please.
I'm recording all this.
Goodbye, Katie. Dropping out of school, maybe running away.
I don't hate you. I'm sorry. I can do that. You see her card?
They're impressive.
She's on a field trip, kids.
Just too good for us.
Is she in yearbook?
Yes.
I didn't know that. Yearbook's going to.
No, I got nothing. Okay, cool.
Nice knowing ya.
Yeah, that's it. You can leave here until I get it.
Oh my gosh, there's like 13 problems.
I know we're never gonna get through it all.
Already almost 9. It takes us like, what, 15 to walk home?
I'm not leaving until they call you out. Or at 9 o'clock.
What if we don't get there?
If you're playing powder puff.
I'm coaching Powder Puff, so I have to go.
I'll just I'm recording this.
So we're going to keep going.
What would I have to do here? It depends on how much we can work here. This is a product, right? So to find derivatives of a product, we also have a rule. F of x times g of x. What's the rule?
F prime times G.
Right, the derivative of the first times the second plus the derivative of the second times the first. So there's a lot of rules that you have to remember. So this is two different functions, right? X squared and sine of x. So we would have to do the product rule here. Do not tell me the derivative of this is 2x cosine, right? That's what people want to do. They're like, oh, that's so easy. Let's just take the derivative and the derivative. The derivative of a power function, the shortcut rule, is that we can just take the exponent and bring it down,
That's the easy part. That's the fun part.
and then you subtract 1 from the exponent. So the 2 comes down, and then you subtract 2 minus 1 is 2x. So the derivative of x squared is 2x. Times the second function, which we'll leave alone, plus new rule, what's the derivative of sine of x? Cosine of x
Cosine of x.
times x squared. And I'm putting the x squared in front of myself. There's not much you can do there, right? If you wanted to, you could factor an x out front, but there's not really a whole lot you can do there. So you want to just leave it? You want to factor the x
No,
out?
just leave it. That's as far as we can go.
These seem really easy. I feel like there's gonna be a trick.
Well, we've only talked about sine and cosine, right? Look at the next slide. What about all the other trig functions? There's derivatives for those too.
Nobody cares. Wait, is that our answer?
That's your answer.
That's it? You don't have to.
Why isn't there a song?
I guarantee you looked it up.
I'll look for a song, but some things in life you just have to memorize without a song, okay?
Is that what your mom taught you?
I didn't learn a song for these. You have to know them. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant x tangent x. And the derivative of cosecant x is negative cosecant negative just negative cosecant cotangent. You're going to have to. I'll make you some little Quizlet cards, and I'll show you how you can use Quizlet to study those. Or you can just make your own index card flashcards. You have to know these.
For English.
And all the answers were there. I know, you told me, remember?
Well, that was on grade 6.
No, it's on Quizlet.
Here are my advice to you on how to help remember these. One, all the C's are negative. What does that mean?
Cosine, cosecant, and
Cosine, cotangent, and cosecant, all of their derivatives are negative. So there is, when we talk about next semester, when we talk about other stuff of inverse trig, remember inverse trig? There's a song to My Humps, only it's called My Trig, and they say all the C's are negative, and it's true, all the C's are negative.
what is the song?
But it's not, that's for inverse trig, we're not there yet. Here's my other advice. Look at tangent and look at secant. You have to kind of remember those. Tangent is secant squared, and then secant is secant x tangent x. If you remember that, I always remember cotangent and cosecant are just like that with the co-functions. See what I'm saying? So like, tangent is secant squared, and secant is secant x tangent x. Cotangent is cosecant squared, so it's like tangent with secant, only it's cosecant. And cosecant is cosecant cotangent, which is like this one, only the co-ones. I don't know if that makes any sense at all. That's how I remember it, so I feel like I'm not remembering 6. Sine and cosine are pretty easy to remember. And can you please stop? If you can memorize tangent and secant, and then you remember that cotangent and cosecant are just like that with the co-ones in front of it. So that's how I remember them. Honestly, like flashcards are really good. That's why next week we will spend a few minutes going around the world until someone gets around the world and wins a prize, practicing them. And you just have to practice them. When we have a test, you get no cheat sheets in here. On the AP exam, you get no formulas. They give you nothing. So like you have to know these derivative rules. You get nothing. On the final exam in here, you get nothing. You get nothing.
They give one on AP chemistry.
You get nothing. So that's why you should be super impressed at how good my scores are. They get nothing. It's on you guys to keep my scores up, just so you know.
All fail.
That's it. You just go.
Adam comes in and everybody else drops out.
2017.
So, okay, so now they can get a little more exciting, like this. So, derivative is y prime. So remember that y double prime means just do the derivative twice. So we talked about last week that if you take the derivative of a polynomial function, it always goes to 0. For a trig function, it's never going to go to 0.
Use the product rule.
So, using our rule, what did we just say the derivative of secant was?
Secant x tangent x.
Secant x tangent x. I had a girl one year that always interchanged the c and the x on secant x. Always.
What?
Sexy.
Like she just did it without thinking. Like she was just like, I don't know why I can't write secant. I always write sexy. And I would just grade it and laugh and
She get AP credit though.
no, that was like my first year teaching. That was back when I was really bad at teaching it.
You had a time where you're really bad at teaching.
Every teacher has a time they're really bad at teaching. But like I taught a really good calculus course, but I did not teach a really good AP calculus course. So all those kids did not get credit from me, but they went to college and got A's in their calculus course very easily. But I didn't have AP stuff figured out for a couple years.
So then they have to do the product rule.
Yeah. So if you want to do the second derivative with trig, it's going to get a little nasty here. Now we have a function times a function, and it's all trig. So it's good practice. What's the derivative of secant x? Secant x tangent x. Leave the second one alone, so that's going to be times tangent x plus, what's the derivative of tangent x? Secant squared x times secant x. It's a lot of secant. So that would be secant x tangent squared plus secant cubed.
That's it, right?
No, say it again.
The secant x times tangent x and then tangent x times tangent x.
No, because it's all multiplication. Like the only time you distribute is when it's addition. Right?
Number one. Because we have to like do the derivative. Because the derivative of we define secant x and tangent x.
So the derivative of secant x was secant x tangent x.
Yeah. But why did you separate those two but you're not separating them again?
You just multiply the terms together. It's like if you draw. I think it helps if you parentheses.
Yeah, it would help.
To separate the terms.
Parentheses aren't important.
Not when it's all multiplication, you don't need parentheses.
I know, but it's just I'm saying.
It helps.
Like that?
I drew parentheses.
See how it's all one term?
Yeah.
So you just multiply it.
If it would have said secant x plus tangent x times tangent x, then you're right, you have to distribute. But you don't distribute when it's multiplication.
But then for the derivative, you have to split them up. Why do you split it up for derivative but not?
But I don't think I am. The derivative of secant is secant x tangent, and then this is the second term, leave it alone. And then over here, the derivative of tangent is secant squared times the secant. So this is like my f of x. This is like my f prime of x. Leave the second one alone. And this is my g prime of x times f of x.
I don't even understand.
I don't understand your question.
It's a
Okay.
Oh, only live 1 minute.
Moving right along.
And that's it, right?
I don't know. We can factor a secant out. I don't know, like what the right answer is of what do you simplify and what do you not simplify. I always hope that something magically simplifies, but I don't think tangent squared plus secant squared equals anything, right?
I think it does either.
So either one of those is okay.
Check your pen.
What's my advice that I tell you when you're talking about what do you do with answers?
Look at the record.
If it's odd, check the back of the book and see how they leave it, and then that's good practice and how you should leave it. I would factor out the secant. All right, I really don't have that many left, right?
Just
About
y prime of y equals
7.4.
5x cos x.
Cosecant x.
Oh.
Do you have to do the product rule on this?
Okay.
Yes. Do I have to do the product rule 3 times?
No.
No, because 5x is, you could just say that's just one function, right? So again, if it helps you, break them up as your f of x and your g of x. So let's see if this one makes more sense. Or maybe you can ask a question on this one, and there's not so many tangents and secants that I'll know what you're asking.
It's alright.
I'm sorry.
No, it's fine.
So this is like my f of x, and cosecant is like my g of x. So the derivative of 5x, again, if we're talking about slope here, derivative means slope. So of a linear equation, that's why it's just 5, or you can use the power rule where you bring the 1 down, so 1 times 5 is 5, and if you subtract 1 from 1, you get x to the 0, which is why this derivative of 5x is just 5 times cosecant x. Plus, I'm going to leave the 5x first, because I like to keep that in front. And then what's the derivative of cosecant x?
Negative cosecant x cotangent x.
I'm going to do negative cosecant x cotangent x. See what I did there?
And we're
I just
done.
factor out 5 cosecant x.
You can factor out a 5 cosecant x if you want. I don't know. Your choice. I'm gonna factor it out. I think it looks better. And I would have 1 minus x cotangent x. But what does that really accomplish? Not a lot. So that's why it's kind of up to you. On a multiple choice question, remember, half the AP exam is multiple choice. You got to be able to match it. So that's why my advice is checking the back of the book. Okay, ready to use the pre-cal?
What? We've just been doing that.
Not really.
What is this?
1 through 10 all.
Let's see if we can.
Find the equations for the lines tangent and normal to the function at a given point. So remember that a tangent line is drawing that line into the curve using the derivative. They give us a point. You know, we've been doing this a lot, but step 1 is we have to do the derivative of this. So want to do, yeah, I think we have to do the product rule. I don't think there's a way around it.
Just not. Probably just not.
We have to.
But like we could just not do it.
So let's do the derivative first. So if it says find tangent line, remember step 1, find the derivative. What is the derivative of sine of x?
Cosine of x.
Cosine of x. Leave the inside alone. Sine of x plus cosine of x. Plus,
Oh my god.
I'm going to, again, I kind of like to just write the first one again. So I'm going to write plus sine of x. And then what would the derivative of sine of x plus cosine of x be? Cosine of x minus sine of x. Barf. We could multiply through if we want. It's kind of up to you. At some point, we have to plug pi force in there and evaluate it. So your choice, do you want to multiply it through and plug in pi force, or just do it now and then simplify?
Cosine of pi force is root 2 over 2.
So, okay, so radians, we'll talk about radians at some point.
All square root of 2 over 2.
But basically, there are pi radians, think of this,
Literally all of it.
in 180 degrees. So instead of talking about degrees in calculus and pre-calculus, we talk about radians. So if you wanted to convert pi force to degrees, you could multiply by 180 degrees in pi radians. Like that's your conversion factor, and you would get 45 degrees. And we'll work that out. We'll figure it out. But basically that's 45 degrees.
Still square root of 2.
So 2 ways to do this. They are all unit circle people. But do you remember in geometry when you talked about special triangles like 45, 45, 90 and 30, 60, 90? You can do that for these, and you can say if you know pi force is a 45, 45, 90 triangle, and you remember the ratio of the sides, we say we're talking about the unit circle, so the radius is 1, 1, radical 2, and then you can do SOHCAHTOA from there. They love the unit circle because the unit circle gives you the ordered pair, which gives you radical 2 over 2, comma, radical 2.
It's really
See,
all
I
that
just,
Yeah, we'll teach him. We'll teach him the intric. Let's just try not to overwhelm him so much.
Just draw it a couple times. That's what I learned. I just drew it like twice.
yeah, I still haven't, I struggle with that.
We'll figure it out.
Unit
But basically, if you know the ordered pair on the unit circle, the x coordinate is always what?
2.
Cosine. So the x coordinate is always the cosine of the angle, and the y coordinate is always the sine. So the reason that they love the unit circle is because if you know the ordered pair, you know the sine and cosine for that angle measure. And I let them listen to a really annoying song that for some reason they like, and we don't like it. So we could plug all that in. So the cosine is radical 2 over 2. There's a whole lot of radical 2 over 2's, right?
Yeah, like 12 of them.
Yeah, it's all radical 2 over 2.
If there's 16 things. And that's it. Oh, 9 o'clock. Time to go.
Wait, what is the term that's just here?
Yeah, this is just 0 because radical 2 over 2 minus radical 2 over 2 is 0. So that's all going to go away. What's radical 2 over 2 plus radical 2 over 2?
2 radical 2 over 2. Twos.
2 radical 2 over 2 is just radical 2, right? Do you agree with that?
Less
2 radical 2 over 2 is just radical 2.
Yeah, that's what I was gonna say.
So then what would radical 2 over 2 times radical 2 be?
2. Oh, 1. It's 2, 1.
If this the whole answer is just
You
one.
get radical 4 over 2, which is really just 2 over 2, which is really just 1. Like all that work and the slope is 1, the derivative is 1.
Let's do 6 minutes of work for the number.
This is how it was for like the first week. It's like, let's do 18 minutes of problems and then the answer is 0 14 times in a row.
If it said just find the derivative, right, we're done. But it says write the tangent line. So remember, the tangent line is the line that goes through the point on the graph that has that slope. So now you have to remember that this is like your slope. This is the point they gave you, and you're just writing that linear equation that goes through that point with that slope value. And so this is where I'm a big fan of point slope form. Because all you have to do is plug in your point, and your derivative is your slope. So what was our point? Pi force 1?
Yeah.
So you get y minus 1 equals our slope, which is 1, x minus pi force.
And we're done.
And remember that that is an equation. You don't have to put it in slope-intercept form. It talked about the normal line up there, but we're running out of time. But just really quick, what does it mean if it says find the normal line?
Inverse slope. No, negative reciprocal slope.
Right. The normal line is the line that's perpendicular to the tangent line. So really, all you have to do is do the negative reciprocal of your derivative, which is really easy because it's just negative 1. And you actually could do that very easily as well. So honestly, here's what today is. Everything we've been doing up to this point, power rule, quotient rule, product rule, tangent lines, only with trig functions now.
I love trig functions.
But they're applicable.
Your brain works with traits for some reason.
Oh,
Right.
9 o'clock, time to leave.
So your homework is 1 through 10 all, and then those other ones. Remember to check your odd answers in the back. Please do not do this whole assignment without checking as you go and do it wrong, right? That's bad. Bad news.
It's really disappointing though when you like do it and then you check it and you're completely wrong on every single one.
That's why you do one and check it, and then you don't go on to the next one until you know. 1 through 10 is just a bunch of just derivatives, nothing crazy, just derivatives. Then the story problems later on, and we'll talk about some of them on Monday. We are having a homework quiz at some point, and I'm probably going to add some of this to it since just keep doing so. It's going to be like a 1 whole day homework quiz. It's going to take so long.
Why don't you just give us some quiz?
I do believe this is the last section we do before we have a test. So that means we're going to have a test next week.
Oh,
If I could have your
gotta
attention,
leave.
students, at this time, any